नमस्कार, आप सभी का बहुत बहुत स्वागत है। आप देख रहे हैं eVidya चैनल नंबर 12 एंड अपार्ट फ्रॉम दिस चैनल यू आर विद अस ऑन आवर यूट्यूब चैनल एज वेल, दैट इज ncertofficial. I am Renu Bhatt with you all, and dear learners and viewers, in this specific session we are going to learn more about solution, and this session is for केमिस्ट्री 12th स्टैंडर्ड स्टूडेंट्स। केमिस्ट्री की 12वीं कक्षा के विद्यार्थियों के लिए हम ये टॉपिक लेकर आए हैं। सॉल्यूशंस क्या होते हैं, कितने इसमें कंपोनेंट्स होते हैं और किस किस तरह से आप इन्हें यूज़ कर सकते हैं, आपको डिटेल में इंफॉर्मेशन देंगे हमारी एक्सपर्ट जो हमारे साथ जुड़ चुकी हैं। लेट्स मीट हर। यू आर मिस प्रीति गौल, यू आर फॉर्मर पीजीटी केमिस्ट्री फ्रॉम समरविल इंटरनेशनल स्कूल, नोएडा। वेरी वार्म वेलकम मैम।
Thank you.
And before we start this particular session, let me share some certain information to all our viewers out there. In case they have any query and any doubt, you can reach out to us through our various medium. आप हमारे एक्सपर्ट से अपने सभी क्वेरीज पूछ सकते हैं। आप हमें कॉल करेंगे हमारे टेलीफोन नंबर पे जो है 8800 440 559. Either you can drop a mail at our email address, that is dth.class12@ciet.nic.in. We would appreciate your effort if you send us your feedback as well. और अगर आप हमारे YouTube चैनल पे हैं NCERT ऑफिशियल पर, तो लाइव चैट बॉक्स पे जाके अपना कमेंट ड्रॉप कर सकते हैं। ये सबसे तेज़ माध्यम है हमसे जुड़ने का, और हम चाहते हैं कि ज़्यादा से ज़्यादा अपनी क्वेरीज़ के साथ आप हमसे जुड़ें। और इससे पहले कि हम ये सत्र शुरू करें, लेट मी शेयर अ वेरी इंपॉर्टेंट पीस ऑफ इंफॉर्मेशन रिगार्डिंग इंडियाज़ G20 presidency. We are indeed very proud that India assumed G20 presidency and will convene the G20 Leaders Summit for the first time in the country in 2023. A nation that deeply committed to democracy and multilateralism, India's G20 presidency would be a watershed moment in her history as it seeks to play an important role by finding pragmatic global solutions for the well-being of all. And in doing so, manifests the true spirit of Vasudhaiva Kutumbakam, or we can say the whole world is one family. With that very important piece of information, let's quickly get back to the session in which we are going to discuss about the topic solutions. So over to you ma'am. क्या कुछ खास है आपके पास हमारे बच्चों के लिए?
Good afternoon, children. I'm sure you are doing very well. Dear children, today I am starting with the very first unit of your class 12 book of the new syllabus, that is solutions. You are very familiar with this term right from junior classes. I think you know very well what are solutions. Solutions are a kind of homogeneous mixture in which we mix two or more than two substances which are dissolved in a liquid or in a solid or gas. So the substance which is in the larger amount, that is called solvent, and the other substance which is in a smaller amount is called solute. So we will be discussing about solutions, so many things about the concentrations, how we can represent concentrations in many ways. We will discuss those, we will discuss Henry's law, and if time allows, we will discuss Raoult's law also. So let's move. So you know there are two parts of solution. The first part is solute, that is which is in the smaller amount or the lesser amount, that is called solute. And that part of the solution which is the greater part or which is the greater amount, that is called solvent. So solute plus solvent is equal to solution. Correct? So
Correct,
let's move on. Any question, ma'am?
Yes, ma'am. Here I would like to know, अगर हम बात करें solute और solutions की, जैसे आप बता रहे हैं solvent की, तो there can be there only one solute?
Oh, that's a very good question. There can be many solutes. We can add two or more than two things in the liquid. As you know, in water, we can dissolve salt, we can dissolve sugar. So there can be two solutes in one solvent, water. But in this chapter, we will consider mainly the binary solutions. Binary solution means which has two components, one solute and one solvent. So the smaller component is solute and the larger component is solvent. So there can be so many types of solutions, as you can see on the screen. The gaseous solution means in which the solvent is a gas. So a gas can dissolve in a gas, liquid can dissolve, and solid can also dissolve in a gas. And you can see on the screen, there are so many examples, mixtures of oxygen and nitrogen, that is air, that is gaseous solution. Chloroform, which is mixed with nitrogen, that is liquid dissolved in gas. And camphor in nitrogen gas, that is solid dissolved in gas. So what is the main part of the solute in solution? We also call it true solution. That means solute particles are very, very small and all the components are in one phase. One phase means either all are solids, all are liquids, or all the components are gases. So we come to the second type of solution, that is liquid solutions. In liquid solution also there are three types: gas in liquid, liquid in liquid, and solid in liquid. And you can see the examples. Oxygen in water is gas in liquid, ethanol in water is liquid in liquid, glucose in water is solid in liquid. Similarly, in solid solution, gas in liquid, gas in solid, liquid in solid, and solid in solid. So you are very familiar with the term alloy, isn't it? So alloy is also a kind of true solution in which a solid is dissolved in solid. So you know how alloy is formed? We take two solids, that means two metals, or a metal or a non-metal. In first we melt them and then we solidify them. So we get a homogeneous mixtures of two metals, or a metal and a non-metal, or more than two metal and a metal, so many things, right? So these are the different types of solutions. Now we will do a quick recap of the expressing concentration that you have done in class 11th also. So in this part, I will be moving little faster because you know all these terms very well. So the first term is mass percentage. Mass percentage, you can see it is the percentage of the component. Mass percent of the component means mass of the component in the solution divided by total mass of the solution multiplied by 100. So this gives the mass percentage of the solution. For example, if we say a 10% solution of sodium chloride, what does this mean? It means that 10 grams of sodium chloride has been dissolved in 100 grams of solution. So mass of solute is 10 gram, mass of solvent is 90 gram. So total mass of the solution will become 10 plus 90, that is 100. So it will be 10 upon 100 into 100. So 100 will be cancelled. So what will be the percentage? It will be 10% solution. You all know very well. So then another type of percentage is volume percentage. Volume percentage means volume of the component upon total volume of the solution into 100. It is same. The difference is instead of mass, we have taken the volume. I'm sure you have understood. So let's move to the third one. Third one is mass by volume percentage. It means that mass of the solute which is dissolved in 100 milliliter of the solution. And this percentage is used in medicines and pharmacy. That medicines we make this much percent of amount of the medicine is dissolved in this much of the solvent. That solvent is generally in volume and component of the medicine is in mass. Correct? So move to the next part. This is very, very important. This is parts per million. Just like percentage, we calculate out of 100. Parts per million, we calculate out of 10 to the power 6. That means ppm is number of parts of the component divided by total number of parts of all the components into 10 to the power 6. So this becomes parts per million or ppm. This is used when the solute is in very, very small amount and in trace quantities. As you know, in swimming pools, you must have smelled chlorine in the swimming pool. So chlorine is added in parts per million. That is a very, very small percentage of chlorine is added in swimming pool. So in this ppm, we can calculate mass by mass, mass by volume, or volume to volume, parts per million. Now comes the most important or very, very important topic, mole fraction. Although you are familiar, but I am discussing it again. So this is denoted by the symbol X. So mole fraction of that component, of one component, is equal to the number of moles of that component divided by total number of moles of all the component. Once again I am saying mole fraction of one component is equal to number of moles of that component divided by total number of moles of all the component. I will give one example how to calculate. If there are two components in a solution, so mole fraction of component 1, that is x1, will be equal to n1 upon n1 plus n2. Means n1 is number of moles of component 1, n2 is number of moles of component 2. So n1 upon n1 plus n2 will be number of moles of component 1 divided by total number of moles of all the components. Similarly, x2 will be n2 upon n1 plus n2. And if we add x1 plus x2, it comes out to be 1. Any question coming to your mind, children?
मैम हम एक बार फिर से अपने सभी देखने वालों से कहेंगे कि अगर आपके मन में कोई भी क्वेरी हो, कोई भी क्वेश्चन हो, तो आप अपने सभी क्वेरीज और क्वेश्चंस हम तक ज़रूर पहुंचाएं। आप एनसीईआरटी ऑफिशियल यूट्यूब चैनल पर जा सकते हैं और वहां पर लाइव चैट बॉक्स में अपना क्वेश्चन ड्रॉप कर सकते हैं। और ये सबसे तेज़ माध्यम है हमसे जुड़ने का, जैसे हमने आपको पहले भी बताया। लेकिन अगर आप हमें टेलीफ़ोन करना चाहते हैं तो आप टेलीफ़ोन के माध्यम से भी जुड़ सकते हैं। हमारा नंबर है 8800440559। और अगर मैम यहाँ पर हम आपसे बात अपनी चर्चा को आगे बढ़ाना चाहें, एज यू आर डिस्कसिंग अबाउट मोल फ्रैक्शंस, राइट, हम यहाँ पे आपसे जानना चाहेंगे, इफ देयर आर मोर देन 2 components, हाउ कैन वी कैलकुलेट मोर फ्रैक्शंस?
That was what I was expecting, ma'am. If there are 3 components or 4 components, in that case, what will we do? Then we will calculate like this. Let me show you. So suppose there are 3 components. Then there will be 3 components. There will be 3 moles. N1 is number of moles of component 1. So mole fraction of component 1 will be equal to N1 upon N1 plus N2 plus N3. Okay? If there are 4 components, we will add plus N4 also, and so on. So number of moles of component 1 divided by total number of moles of all the component. Similarly, X2 will be what? N2 upon N1 plus N2 plus N3. Or X3 will be N3 upon N1 plus N2 plus N3. And in that case, X1 plus X2 plus X3 will be equal to 1. I hope this is clear to you.
Yes, ma'am.
So we move to the next part, that is, we give you one question. Deepak puts 76 grams of sodium iodide in 500 grams of water. So we have to calculate the mole fraction of the solution. So mole fraction of the solution, how we will calculate the mole fraction of solution? Mole fraction of solution, here it means the mole fraction of the solute. So let us calculate the mole fraction of solute. So what is given here? Mass of the solute is given as 76, that is sodium iodide, NaI, has the mass 76 gram. This is what? W2, right? And molar mass of NaI, we will calculate. Mass of sodium is equal to 23 units plus mass of iodine is equal to 127. So this is equal to 150. So molar mass of sodium iodide is 150 grams per mole. So number of moles of NaI and NaI is equal to given mass upon molar mass. We say W2 over M2. This formula you must be familiar with. So W2 is 76 and M2 is 150. So when we calculate, it comes out to be what? 0.507 moles. Okay. Similarly, the other component is water. So what is the mass of water given? W1, that is mass of water is 500 gram. And molar mass of water, M1, that is molar mass of water, MH2O, that we calculate, it comes out to be 18 grams per mole. Clear? So what is the number of moles of water? NH2O is also equal to W1 upon M1, that is given mass of water upon molar mass of water. So W1 is 500 upon molar mass is 18. That comes out to be what? 27.8 mole. So now tell me what will be the mole fraction? Mole fraction will be N1 upon N1 plus N2. So mole fraction of NaI will be equal to N1, that is 0.507 divided by N1 plus N2, that is 0.507 plus 27.8. So should I do the calculation or you will tell me after 5 minutes? After few minutes, I will tell you the answer. Till then, you do the calculations. All right?
Sure,
So
ma'am.
what will be the unit of this mole fraction? Tell me what unit will be? No unit. Because upper side also it is number of moles, and lower also it is number of moles. So there is no unit of mole fraction. Mole fraction has no unit. It is a ratio. So ratios do not have any unit. Right? So have you calculated? The answer comes out to be 0.018. This is the mole fraction of sodium iodide or mole fraction of the solution. Once again I am repeating. First it is given the mass in grams of sodium iodide is 76. We calculate the molar mass, that is the molecular mass, which comes out to be 23 plus 1, 27, that is 150. So number of moles of NaI, W2 over M2. Children, for solute, we write 2's, W2, M2, all the 2's will be for solute. And for solvent, we take it as W1, M1, etc. So W2 by M2, 76 by 150, that is number of moles of sodium iodide is 0.507 mole. Similarly, mass of water is 500, molar mass of water is 18. So number of moles of water is 500 upon 18, that is 27.8. Is number of moles of sodium iodide divided by number of moles of sodium iodide plus number of moles of water, that is comes out to be 0.018. That is how we calculate the mole fraction. This is very, very important for you to learn because it will be used later on in other topics in the same chapter. So we move on.
Sure, ma'am. Please continue.
Yeah. Now, next topic is molarity. This is again a very, very important topic. According to molarity, 1 minute. Molarity is number of moles of solute which are present in 1 liter of the solution. That is molarity. number of moles of solute present in 1 liter of the solution, as you can see on the screen.
Ma'am,
so molarity.
Hey,
Yes, ma'am.
I'm sorry I'm interrupting you, but we are not able to see your PPT, ma'am. Could you please share your screen?
Once again, I will do that.
Yes, ma'am.
Now you are able to see?
Yes, ma'am.
Yes. So molarity is the number of moles of solute present in 1 liter of the solution. It is represented by the symbol capital M. So number of moles of solute upon liters of solution. So again, I will tell you, W2 we write mass of the solute, M2 is the molar mass of solute, V is the volume of solution in milliliter. So when we do the calculation, number of moles of solute is, as I told you earlier, given mass upon molar mass, that is W2 by M2 of solute. Volume in milliliter is V milliliter. So in we calculate in liter, we divide milliliter by thousands to get it in liters, V upon 1000. So molarity comes out to be number of moles, that is W2 by M2 upon volume in liter, V by 1000. So when we rearrange, the formula comes out to be W2 into 1000 upon M2 into V. This is a very, very important formula. Using this formula, you can directly calculate the molarity. Because mass of the solute will be given, molar mass you can calculate, volume will be given. So you can calculate the.
Right. Ma'am, are we audible to you? Hello? Hello?
Calculate the molarity of a solute.
Ma'am, are we audible? Yes, ma'am. Ma'am, here I just need to ask you, please explain to all the viewers out there, which one is better, molality or molarity, ma'am?
Ma'am, I will give you the answer after some time when I discuss molality.
Okay, ma'am.
Okay, after that is a very great question. That is very, very important question which is asked in Viva, also in theory in class 12. Okay, that's a very good question. So calculate the molarity of a solution that contains 5.8 gram KCl in 550 milliliter of solution. And atomic masses of potassium 39 unit, chlorine is 35.5 unit. So children, you will be able to do this by using that formula. So what is the formula? We will use this formula and we will do the calculation. Okay. So now see, the formula is molarity is equal to W2 into 1000 upon M2 into V, and unit is moles per liter. So what is given here? W2 is given 5.8 gram. M2 of KCl we will calculate KCl. So K is 39 and Cl is 35.5. Atomic masses are given. So this comes out to be 74.5 grams per mole. Okay. So M2 is given, V is given. V is what? 550 is V. So then we will calculate M. M is equal to 5.8 into 1000 divided by what? Divided by 74.5 into 550. So it will come out to be what? This will be equal to 0.14 m or moles per liter. Clear? So that is how we calculate the molarity. Now we come to the next topic, that is molality. Now, molality is again very important topic and you will be using it. So it is defined as the number of moles of solute present in 1 kg of solvent. So what is the difference? There was number of moles of solute present in 1 liter of solution, and here number of moles of solute present in 1 kg of solvent. And what is the formula? Formula is, when we calculate just like molarity, W2 over M2 upon W1 into 1000. So we will calculate the molality also. Now this is the question. Calculate the molality of a solution prepared by placing 10.3 grams of MgCl2 in 2000 gram of water. Atomic masses are given. I am sure I will leave the answer for you, and while I discuss the question asked by ma'am earlier, you have to do the calculation. So we will do the calculations now. You also start doing the calculation. So the calculation is, what formula is? Molality is equal to W2 into 1000 upon M2 into W1. So what is given? W2 is given 10.3 grams. M2 we can calculate for MgCl2 is equal to 24 plus 35.5 into 2. So this comes out to be what? This comes out to be 95 grams per mole. Alright? And W1 is given what? What is the amount given? $200 grams. Right?
Right, ma'am.
200. So now we will do the calculation. We will put the values in this and you will do the calculation yourself. Okay, 10.3 into 1000 upon 95 into 200. And what will be the unit? Unit will be moles per kg. So unit of molality is moles per kg. So while I discuss the answer asked by ma'am, all of you do the calculations and then I check your calculation with me. So ma'am has asked a very important question, which one is preferred, molarity or molality? So children, you know molarity is based on volume, amount of solute present in, number of moles of solute present in 1 liter of solution. And molality is number of moles of solute present in 1 kg of the solvent. So if you raise the temperature, volume will change or volume changes with temperature. But mass does not change with temperature. So if we change the temperature, molarity will change. But molality will not change. Therefore, molality is preferred in performing experiments if we have to change the temperature of the system, and molarity is preferred when there is no change in the temperature. So which one is preferred? Molality, because it does not change with temperature as mass does not change with temperature. No volume is used in molarity as you can see here. So have you calculated? The answer comes out to be, you check your answer with me, that comes out to be 0.54 mole per kg, or it is also written as small m. So you can write small m, you can also write 0.5 mole per kg. Alright? So now we move on to the very, very important topic, that is solubility. Children, You know, when we dissolve salt in water, it is soluble in water. If we try to dissolve sugar in water, it is also soluble. But if we try to dissolve oil in water, is it soluble? No, it is not soluble. So we can define the solubility, the maximum amount of the substance that can be dissolved in a specified amount, solute, minimum maximum amount of the solute which can be dissolved in a specified amount of solvent. I will give you one example. If you take 100 ml of water, and in 100 ml of water, if you add 5 grams of sugar, it will dissolve. You keep on adding sugar, it will keep on dissolving. But after some time, what will happen? A time will come when no more sugar can be dissolved in the same volume. When you heat, it will dissolve. So I am going to discuss such solutions. They are saturated and unsaturated solution. Unsaturated solution means in which more solute can be dissolved at the same temperature, and a saturated solution in which more solute cannot be dissolved at the same temperature. If we heat, we can dissolve more solute. Suppose we have dissolved maximum amount of sugar in a solution in water. Now you see some sugar is left behind. It is not soluble. So if you heat this mixture, what will happen? This much sugar will dissolve. And if we cool it, then again what will happen? Some sugar will separate out because solubility decreases on cooling down and solubility increases on heating. But this is not so for all the substances. This is so for those solute in which are some reactions are exothermic and some processes are endothermic. So those processes in which heat is absorbed, when we dissolve something and heat is absorbed, in that case we can dissolve more solute on heating. And there are some processes which are exothermic. That means when we dissolve something, heat is produced. For example, NaOH. If you dissolve NaOH, the solution becomes hot. Then in that case, when we heat, solubility will decrease. So as you can see on the screen, solid solubility increases with increase in temperature. But if the dissolution is an exothermic process, then the solubility will decrease. Then there is one more factor. There are two kinds of solvents, polar solvent and non-polar solvent. As you know, water is a polar solvent. So in water, we can dissolve polar substances like ionic compound, like NaCl, MgCl2. All the ionic compounds will easily dissolve in water. So it is said like dissolves like. But if we try to dissolve non-polar substances, we will not be able to dissolve. For example, we cannot dissolve oil. But there are some substances which are non-polar or in which are covalent, but they dissolve in water. In that case, it is hydrogen bonds. Those substances which can form hydrogen bonds with water, they dissolve in water. So we then move to the next topic, that is solid solubility and pressure. Do you think pressure will have any effect on the solubility of solids? No. Pressure, because solid and liquid, if we dissolve a solid in liquid, liquid also is not affected by pressure. Solids are also not affected. There is no change in volume on applying pressure in case of solid and liquid. So solubility also is not affected by applying pressure because these solids and liquids are non-compressible. They are incompressible and there is no change when we apply pressure. So now we come to the topic solubility of gas in a liquid. This is a very, very important topic. And in this topic, we will see how gases dissolve in liquid and what is the importance of this thing in our life, in our day-to-day life. So you can see here, children, like
Yes, ma'am.
oxygen dissolves to a very small extent in water. But there are some gases like hydrogen sulfide, ammonia, they dissolve, they are highly soluble in water. So how this solubility is affected? This solubility of gases in liquids is affected by two components, two factors, that is by pressure and by temperature. So can anybody tell me, fish are more comfortable in cold water or in hot water? I know you will say cold water. Yes, because when the temperature increases, solubility of gases in liquids or in water decreases. Because what happens when we increase the temperature? So you know, particles of gases, they have high energy. When we increase temperature, they start moving faster and their escaping tendency increases, so their solubility in liquids decreases. So lower the temperature, greater is the dissolution of gas in the liquid. That is why in cold water, more oxygen is dissolved in water, so fish are more comfortable in cold water. So there is a law given by Henry. As you can see here in the graph, you can see carbon dioxide is quite soluble in water, but oxygen, nitrogen, they are very less soluble in water. And when we increase the temperature, what happens? Solubility decreases. So on the lower side, on the x-axis, it is solubility. On the y-axis, it is solubility. On the x-axis, it is temperature. So as we increase the temperature, solubility of gases decreases at higher temperatures. All right. So now we will calculate, or we will create a relationship between pressure and solubility of gases, and this relation was first of all given by Henry. So that is called Henry's law. So according to Henry's law, solubility of a gas in a liquid is proportional to the pressure of the gas over the solution. As you can see in the figure, there are two containers. Volume of the liquid is same here, and volume of the two containers is also same. At lower pressure, the solubility of gas will be less. There are less number of particles of gas, so solubility is less. When it is compressed, particles come closer and their
Hello, ma'am, are we audible? हेलो, तो आप सभी को हम बता दें कि केमिस्ट्री के 12th स्टैंडर्ड के स्टूडेंट्स के लिए हम लेकर आए हैं टॉपिक सॉल्यूशंस, और हमारी एक्सपर्ट प्रीति मैम आपको बहुत ही डिटेल इन्फॉर्मेशन दे रही हैं सभी सॉल्यूशंस के बारे में. एंड शी वाज जस्ट टेलिंग अस अबाउट हेनरीज लॉ. अगर आपके मन में कोई भी क्वेरी आए, आप हमें ढेर सारे मैसेजेस हमें हमारे यूट्यूब चैनल पर मिल रहे हैं, बट वी वुड अप्रिशिएट इफ़ यू सेंड अस योर रेलिवेंट क्वेश्चंस रिलेटेड टू दिस पर्टिकुलर टॉपिक ओनली, दैट इज सॉल्यूशंस. आप हमारे यूट्यूब चैनल NCERT ऑफिशियल पर जा सकते हैं, लाइव चैट बॉक्स पर जाके अपना कमेंट ड्रॉप कर सकते हैं. ये सबसे तेज़ माध्यम है हमसे जुड़ने का, और आप अपनी क्वेरीज़ के साथ हमसे ज़रूर जुड़ें. और अगर कोई भी क्वेरी है आपकी इस पर्टिकुलर टॉपिक से जुड़ी हुई, सोल्यूशन से जुड़ी हुई, तो आप हमें ज़रूर बताएं. हम वापस कोशिश करते हैं अपने एक्सपर्ट से जुड़ने के लिए. हेलो मैम, आर वी ऑडिबल टू यू? हेलो
hello, yes.
Are we audible
My
to you, ma'am?
connection from the laptop lost.
Okay, could you please continue with your presentation, ma'am? Or your...
Yeah, my connection from laptop is lost, so I'm just trying to connect again.
Okay. So, dear learners and viewers, we have learned a lot about solutions, and अभी हम हेनरीज लॉ की बात करने वाले हैं, और उसके बारे में डिटेल में इंफॉर्मेशन आपको मैम बताएंगी. हमारे एक्सपर्ट हमारे साथ हैं. हमारी एक्सपर्ट हैं प्रीति गोयल, और हम सॉल्यूशंस की बात करें. दिस इज़ फॉर केमिस्ट्री स्टूडेंट्स 12th क्लास, 12th स्टैंडर्ड के स्टूडेंट्स के लिए हम ये टॉपिक लेकर आए हैं. और हम एक बार फिर से कोशिश करेंगे अपने एक्सपर्ट के पास जाने के लिए. हेलो हेलो Ma'am, are we audible to you now?
Yeah. I am audible.
Is that fine?
Am I audible?
Quite audible, ma'am.
Yeah, I will discuss. So children, we were discussing Henry's law. So
Yes, ma'am. So by the time our expert is trying to connect with her device only, let me share a very important piece of information with you all regarding NCERT textbooks. NCERT textbooks for the
meanwhile,
year.
I can tell them one question to solve, ma'am.
Ma'am, let me
yeah.
complete my announcement, only then we can come
Okay,
to you. Yes, ma'am. So NCERT textbooks for the year 2023-24 are available throughout the country. These textbooks may be purchased directly from NCERT sales counters located at New Delhi, Ahmedabad, Bengaluru, Kolkata and Guwahati. These sales counters will be functional on all the weekdays, including all the registered holidays, Saturdays and Sundays as well, from 9:30 a.m. to 6 p.m. And you may also place order for the books through our online website, that is ncertbooks.ncert.nic.in. I beg your pardon, it's ncertbooks.ncert.gov.in, and these books will be delivered at your doorsteps with no delivery fees. And in case if you want the soft copy of all those books in PDF version, it can also be downloaded online from NCERT, Diksha, ePathshala website and from our mobile app as well. Please visit our website, that is ncert.nic.in, to know more about the authorized vendors. And with that note, let's quickly get back to the session. मैम, हम आपके पास दोबारा आना चाहेंगे. हेलो मैम, आर यू देयर? मैम, आर वी ऑडिबल टू यू? आर यू देयर?
So when the pressure is high over the solution, solubility of the gas in liquid increases. So now I will show you this figure. In this figure you can see this is the liquid in both the containers and the dark blue portion is the gas. So we have put W1 weight over the piston. So there are lesser number of particles here in the liquid phase. So when we put more weight or we increase the pressure, piston comes down and the gas over the solution is compressed, and then you can see here that more number of particles gets dissolved in water. So as the pressure increases, solubility of the gas increases. So this is Henry's law, and in terms of partial pressure and mole fraction, a mathematical relation is there that P is equal to KH into X. P is the partial pressure of the gas in vapor phase, KH is Henry's constant, and X is the mole fraction of the gas in solution. So this formula we will use in calculation. Again I am explaining, according to Henry's law, partial pressure of the gas over the solution is equal to the mole fraction of the gas multiplied by a constant, that is Henry's law constant, or KH. So higher the value of KH, lower is the solubility of the gas. And if we plot partial pressure versus mole fraction, we get a straight line. This shows that partial pressure is directly proportional to the mole fraction. Higher the partial pressure, higher will be the mole fraction, or higher will be the solubility. And here you see in this table, there are so many gases: helium, hydrogen, nitrogen, oxygen, argon, carbon dioxide, etc. And their values of KH is given at different temperatures. You will first look at for nitrogen and oxygen. Nitrogen at 293, the value is 76.48, and at 303 K, the value is 88.84. So what does it indicate? Indicate that value of KH increases on increasing the temperature. So if the value of KH will increase, what will decrease? Solubility will decrease. Same is the case for oxygen. At 293, the value is 34.86, and at 303, it is 46.82. So here again, solubility of gases decreases on increasing the temperature. And lower the value of KH, higher will be the solubility. So which gas will be the most soluble here? Which is the lowest value of KH? Lowest value of KH is what? Formaldehyde, 1.83 into 10 to the power minus 5. So this is the most soluble substance. All right. So what effect of temperature is, higher the temperature, lower is the solubility, and that is why fish are more comfortable in cold water. All right. Now we will discuss some applications of Henry's law. The first great application is at higher altitude. You know, there are climbers who keep on climbing. And what is the pressure of the air at higher altitudes? At higher altitudes, the pressure of the air is less, so amount of oxygen is less. So when the amount of oxygen is less, and there are these people are working very hard, they are climbing hills again and again, so the volume of oxygen in their blood becomes less, or low concentration of oxygen in their blood causes a simple condition, a symptoms of some condition which is called as anoxia. In this, they are not able to think clearly and they become weak. So oxygen is really very important. At higher altitudes, one should take proper rest. If you go to higher altitudes, some places there you are asked to take bed rest for one day. If you go to lake, very high altitude, you have to take rest for one day and then next day you have to work. Now another one is scuba divers. You know scuba divers who go down deep in the sea and they carry the oxygen cylinders with them. So what happens when they go down in the sea? The pressure inside the sea increases, and when the pressure is high, what will happen? Solubility will be more. So air will dissolve in greater amount in their blood. But when they come up, what will happen? Then solubility will decrease. So whatever air had dissolved, it will start coming out. And in this case, if they carry the normal air cylinders in which there is 80% of nitrogen and 20% of oxygen, you know very well. So that more nitrogen dissolves in blood, and when they come out on the surface, the oxygen starts coming out through the capillaries. Oxygen bubbles block the capillaries, and this is a very painful medical condition. It is called bends. It is very painful and dangerous to life. So to avoid this, what happens? They carry diluted air. So scuba divers, they fill diluted air, that means which carries 11.7% helium, 56.2% nitrogen, and 32.1% oxygen. So this is the oxygen cylinder. This percentage you must learn, and this is very important, and this is to avoid bends. Right?
Ma'am, here what strikes me
one
is
more important thing, that is soft drink.
right.
So in soft drinks, what happens? When you open the Coca-Cola bottles, what do you see? The gas starts coming out, the gas fizzes out, isn't it? Why does the gas come out? It is because inside the Coca-Cola or cold drink bottle, the carbon dioxide gas is filled at very high pressure. So when we open the bottle, the pressure becomes less and it becomes equal to the atmospheric pressure. So solubility of carbon dioxide decreases when the pressure is lowered. So it starts coming out and it fizzes out. And this is also according to Henry's law. All right. So now we will do one question on Henry's law. Henry's law constant for carbon dioxide in water is 1.67 into 10 to the power 8 Pascal at 298 K. So this is value of KH. You have to calculate the quantity of CO2 in 500 milliliter of soda water, one packed under 2.5 atmosphere, and CO2 pressure, atmospheric pressure at 298 K. So the pressure is 298 K. The CO2 second time, this is a misprinting. So when the pressure is 2.5 atmosphere, we have to calculate the what? How much carbon dioxide is dissolved in water. So which formula you will use? Same formula, that is Henry's law formula. So should we solve this or you will do on your own? So children, let's see. So what is Henry's law constant? Formula P is equal to KH into X. So we know the value of Henry's law constant. We know the pressure also. So how much pressure is given? P is given 2.5 atmosphere. And KH is given as 1.67 into 10 to the power 8 Pascal. But you see, one unit is in atmosphere and one is in Pascal. So we have to change into Pascal. So when we change into Pascal, we have to multiply it by 1.01325 into 10 to the power 5. So this becomes this much Pascal. So the pressure, partial pressure is this much Pascal, KH is this much Pascal. We have to calculate X. So what will be the value of X? X will be P upon KH. So what is P? 2.5 into 1.01325 into 10 to the power 5 divided by 1.67 into 10 to the power 8. So what is the unit? No unit of mole fraction.
Ma'am, here let me tell you that
Then
we have.
calculate. I'm calculating this for you.
I hope I am audible to you. I hope.
Calculate only yourself. So this comes out to be, as the time is less and I want to calculate, it comes out to be 0.00152. So mole fraction of carbon dioxide is this much. Now children, what is mole fraction?
Ma'am, let me tell you that we have only 4 more minutes left for the session, ma'am.
NCO2 is equal to what? Number of moles of CO2 divided by number of moles of CO2 plus number of moles of water. Isn't it? This is what we discussed earlier. So number of moles of CO2 we have to calculate. We can calculate number of moles of water. How much water is given? Number of moles of water, how we will calculate? Given mass upon molar mass. So given mass of water is given 500 gram, molar mass of water is 18. So this gives out to be 27.78 or 27.8. So number of moles of water is 27.8. As we know, this is a very, very dilute solution. So, and number of mole of CO2 is very, very small than number of mole of water. So, what we can do? We can neglect number of moles of CO2 in the denominator. So, we can calculate NCO2 is equal to NCO2 upon NH2O. Alright? Sorry, XCO2. This is X.
Ma'am, please sum up.
Alright. So this is XCO2. One. XCO2 is equal to NCO2 over NH2O. So XCO2 we have just calculated 0.00152 is equal to NCO2 over 27.8. So you can calculate NCO2, that will be equal to this multiplied by 27.8. So this number of moles of carbon dioxide will be dissolved in 500 milliliter of water. That is, then we can calculate the further. So when we calculate, it comes out to be what? We will do quickly. This NCO2 comes out to be 0.042 mole. And you know what is the
So, and 0.0242 mole of carbon dioxide is dissolved in 500 milliliter of water. If we want to calculate into grams, then it will be WCO2 will be what? 0.042 multiplied by its molecular mass, that is 44. This will be equal to 1.848 gram. So this is how we can calculate Henry's law. Hope you have understood well.
Yes, ma'am.
Any questions you can write on the YouTube link. I will be able to answer on YouTube link. And all your further queries you can send me through on the YouTube link.
Ma'am, you have explained this very beautifully and in detailed manner.
And I'm not, you are not audible to me, ma'am.
I guess I'm audible to you now, ma'am. You have explained this very beautifully and in a detailed manner. हमें कोई क्वेश्चन नहीं मिला है हमारे इस पर्टिकुलर टॉपिक से जुड़ा हुआ, और हम यहाँ पर अब इस सेशन को यहीं पे वाइंड अप करना चाहेंगे क्योंकि समय हमें बिल्कुल इजाज़त नहीं दे रहा है हम इस सत्र को आगे बढ़ाएं. सो वी हैव टू रैप अप दिस सेशन हेयर ओनली, बट यू स्टे ट्यून टू eVidya channels and NCERT official YouTube channel for more informative program. Me, Renu Bhatt, is taking your leave. Namaskar.